I welcome you to the Symposium number 44, Biosafety and TB Infection Control, Sharing Knowledge, Challenges, and Solutions in Laboratories. And as we know, biosafety varies a lot from lab to lab, within countries, between continents. And what we hope to do here is make sure people understand that it shouldn't vary that much. You know, we should base our interventions on risk, that yes, there are differences in infrastructure, and then we have to balance risk and infrastructure so that we can have safe environments to work. And we'll also learn about effective approaches to solving this with our 5 speakers. I'm Paul Jensen with CDC out of Atlanta. Next to me is...
Thank you. I'm Dr. Alain Nyaruhirira from Management Science for Health as a Senior Technical Advisor for Laboratory Service in the region.
So we're going to go ahead and get started. I'm going to be the timekeeper. What we're going to do is ask each speaker to talk for 10 minutes. There's a total of 15 minutes slotted, but we'd like the speakers to speak for 10 minutes. We'll go through all the presentations, and then that allows some time for discussion, because I think with the discussion we'll be able to lead to or point to some of the different speakers, not just have one speaker answer a single question. So with that, let me go ahead and introduce the first speaker, Chris Gilpin. Chris is a senior lab guy. That's the official title, right?
I think so.
Okay.
It's close.
For WHO Global TB. And Chris has been there for quite a few years. And he's going to talk about overview of risk assessment approach, story of implementation.
Okay. Thanks, Paul. Good morning, everyone. Firstly, declare no conflict of interest with this presentation. For this presentation, quickly give an overview of risk assessment, what that means, and the classification of TB laboratories. What are some of the essential biosafety measures for TB laboratories? And look at the levels of risk for the different procedures that are performed in different laboratories. So firstly, starting off with the definition, what is biosafety? And it's the application of a combination of administrative controls, containment principles, laboratory practices and procedures, safety equipment, and lab facilities to enable the safe work of potentially infectious microorganisms. So it's no one thing. It's not just the infrastructure. It's not just the cabinet. It's all of these principles, all interrelated with one another. So when we look at a tuberculosis laboratory network, we have different levels of sophistication of the lab infrastructure and the biosafety precautions that are in place, depending on where that lab is. So at the central level, we have very few, in most high-burden countries, very few highly sophisticated laboratories with all of the biosafety precautions in place to allow us to do the most hazardous work, which is culture, and then drug susceptibility testing. There's a larger number of the intermediate levels that have not as sophisticated infrastructure, but there may be rooms that would allow, and continuous electrical supply that would allow some of the molecular assays to be performed. And then at the lowest level, this is where the bulk of our patients are seeking healthcare or seeking a diagnosis. This is where we have the lowest levels of infrastructure, and so we can have to restrict the types of tests that we do at the lowest level. So these are the list of WHO recommended diagnostic technologies. At the central level, all of the tests recommended by WHO can be performed there. As we move down, we're restricted at what can be done at the intermediate level, and then at the periphery, we're really restricted to microscopy and the use of the GeneXpert assay. And when we talk about the risk groups of organisms and the associated biosafety level, the principles are, depending on the risk group of the organism, normally correlates with a biosafety level that you would use. And these risk groups are actually determined based on the level of risk of a particular pathogen to an individual as well as the community, and whether there's treatment available. So for a risk group 1, there's no or low individual or community risk. For risk group 2, we see a moderate individual risk and low community risk, and treatments are available. Risk group 3, we see high individual risk, low community risk, but even though treatment may be available, there's still serious consequences. And for risk group 4, we're talking about a high level of individual and community risk for which treatment may not be available. And if we think about TB and the type of samples we get in a TB laboratory, we could talk a sputum sample. Preparing a smear, well, even though it's quite difficult to aerosolize a sputum sample unless you're very careless with it. So, and the number of organisms in a sputum sample are much lower than what you'd have in a positive culture. So where do we actually place TB in terms of these risk groups? For a sputum sample, for example, we may place it in risk group 2. If we're talking about a cultured isolate of XDR or MDR TB, we could be considering it as a risk group 4. So we can't just apply these very high levels of biosafety to all of our TB testing. So we need to be doing a risk assessment to actually apply the most appropriate biosafety measures for the various procedures that we're doing. So AFB microscopy remains a primary diagnostic tool for the bacteriological confirmation of TB. We estimate there's more than 37,000 microscopy laboratories in the 30 high burden countries, and we have GeneXpert rapidly being scaled up as a replacement for microscopy. And so when we were developing this biosafety guidance, we needed to have some practical guidelines that was going to be appropriate for the lowest levels of the lab network. And so this manual that we issued in 2012 uses a risk-based approach. It describes the minimal precautions that are needed for performing different procedures in the TB laboratory, and does not refer to the different biosafety levels, the BSL level 1, 2, and 3. We move away from that and talk about the risk of doing particular procedures. Well, many times we hear people talking about their TB laboratories as a BSL level 3 laboratory or a BSL level 2 plus laboratory. We really think in the TB world we should be moving away from these BSL levels, and we use the term a TB containment laboratory, a laboratory that has the appropriate containment measures in place that can minimize the risk of a laboratory-acquired infection. And when we consider the approaches to a biorisk assessment, we have to consider many of these aspects: the pathogenicity of the infectious agent, the route of transmission. TB is primarily transmitted through the inhalation of infectious aerosols, agent stability and the infectious dose. So depending on what sample you're manipulating, the dose will be different with a culture versus manipulating a sputum sample, as well as the concentration of organisms in the sample. So what type of lab procedures are going to be done will actually affect what is the risk. So if you have a sputum that you're making a smear, relatively low risk of generating aerosols. Similarly, getting a sputum sample and inactivating it to do an GeneXpert test, you're not generating aerosols. But as soon as you liquefy that sample and then start pipetting, as you would need to do for a line probe assay, for example, or to inoculate a culture, you're all of a sudden allowing aerosols to be generated. And this is the most hazardous aspect of the work in any TB laboratory. The skill level and vulnerability of the at-risk person. So if you've got an inexperienced technician working in a culture and DST laboratory, they're at greater risk of making a mistake and of getting a laboratory-acquired infection. And similarly, people at different risk, HIV positives or even pregnant staff, really need to be Yeah, you've thrown me now. Be aware of their increased susceptibility, as well as the epidemiology of the disease. If TB's of low prevalence in your particular setting, the risk of doing any of the procedures is less compared to working in a high TB burden setting with high rates of drug resistance. So I'll skip over this, but we'll move to this classification of, sorry, I will go back to this. So in order for this manual that we produced, what we did do is an individual risk assessment for each of the types of procedures that WHO recommends. So, and for each of these, we identified the inherent hazards, decided who might be harmed and how, and evaluated the risk to decide on precautions. And this was used to actually establish the classification of low, moderate, and high risk according to each of these procedures. And so for low risk, we're talking about direct sputum smear microscopy, expert, moderate risk, processing sputum samples for inoculation in culture media, or performing direct line probe assays. And then the greatest risk is manipulation of specimens for culture or performing drug susceptibility testing. So I won't go into the specifics of the individual laboratory infrastructure for the low, moderate, and high, but just to focus on the minimal requirements for a high TB laboratory, high risk TB laboratory or TB containment. And so what we do emphasize is that you do need to have a double door airlock. So you have a physical barrier separating the functionally clean from the dirty areas, separate air inlet, as a minimum, venting of the BSC via a thimble. I think that's for me, isn't it, Paul? Aerosol containment in the terms of properly functioning biological safety cabinets, negative pressure monitoring to make sure that you do actually have a pressure differential within the containment laboratory compared to the outer areas, as well as the appropriate use of personal protective equipment. So I'll stop there, and there are many options for how we can go about establishing the necessary ventilation requirements in the different types of laboratories. And we've identified this as one of the key priorities that we need to be addressing as a community to provide guidance to countries on different options they have or can implement to make sure there is adequate ventilation even in low-level laboratories, so that our laboratory workers can perform different levels of testing safely. So I'll stop, and thanks for your attention.
Thank you, Chris. And then I'm going to set the alarm for me, too. So.
Yeah, thank you, Chris. I would like to introduce Paul Jensen, the second presentation. And Paul Jensen is a specialist on infection control from Center of Disease Control, CDC, Atlanta office. Thank you.
Okie dokie. So I'll try to stay within the range. This document on the right is the one that Chris was talking about, which is the 2012 document. I'm going to try to talk about infection control and biosafety. There are other references, the 2004 WHO Biosafety Manual, and also CDC NIH has one. But there are also infection control references. What I want to do is, Chris gave you a definition of biosafety. I'm going to give you a different version, but we're still telling the same story. With biosafety, we don't want workers to infect other workers. We don't want workers to contaminate cultures or specimens, and we don't want them to aerosolize something in the lab. Just like we don't want a specimen to be aerosolized, inhaled, or infect the worker, or the lab, or a different worker. So it's really, we're talking about transmission. When we talk about infection control, it's kind of the same thing, except what do? We add the patient. So a specimen doesn't move around, but patients do. So when we're talking about infection control and biosafety, they're very, very similar, and we're going to apply, or have always applied, very similar measures. So when we talk about lab biosafety, a lot of its administrative controls are standard practices. The only real difference between infection control and lab biosafety is we throw respirators into the standard procedures. Not for everybody, but when the risk requires it, people are required to wear respirators. We also have our primary containment devices or safety equipment, and lastly is your overall facility or secondary containment. When we talk about infection control, we've got the administrative controls, environmental, and then respiratory protection. Basically, we apply what is necessary in infection control. We don't go through all the environmental controls before we put respirators on. We may find, based on risk, you'll need respirators. So again, this is really just to let you know when you talk infection control or biosafety, it's a similar risk-based process. And we also want to have a KISS principle. And KISS A doesn't mean kiss an architect. I'm not an architect. But really, it's just keep it simple, sustainable, and different people use different things. I like achievable, some will say affordable, but the idea is don't make it any more complex than you have to do it. Where do we start? Well, as Chris mentioned, we have to understand the risk. Then we have to prioritize what we're doing and prioritize our resources. And then plan for sustainability from the beginning. Don't just plan on getting a new lab or a piece of equipment, but how can we sustain that piece of equipment over the years? So here's a lab, I blanked out the name, but it's a lab that was designed in 2011, or 2010, renovated 2011, and to this day it's not operational. There are many consultants go in, some say everything's working fine, some say start all over again. And next week I'll make my third visit there this year. Anyway, it's a national TB reference lab. They do culture with solid media, liquid media. The risk, based on their risk assessment, they said potential for high. Why didn't they just say high? With proper work practices and equipment and stuff, their goal is to keep the risk as low as they can. So to be optimistic, they said potential for high. So when you do a risk assessment, depending on the group, you may come up with a different answer for level, but what you apply is going to be the same. So I'm less concerned about how you classify the risk. It's really what you do. And the conclusion was, as Chris mentioned, there's sort of two different terms. By WHO 2012, and we didn't compare presentations beforehand, so I'm glad we agree, they said they need a TB containment lab, or essentially a BSL 2+. It'd be a 2 facility and has some 3 requirements. Are biosafety cabinets required for BSL 2? No. By WHO 2004, it says essentially optional. Based on the risk assessment, you may say yes. When you get to BSL 3, it's required. So it's not an official term, BSL 2+, but it's some 2, some 3. The TB containment lab allows you the flexibility to select what you need to control the risk. So here's a layout. If you take a look at the right corner, the left room is going to be the TB lab. The right is for other diseases. They have an anteroom between the two labs, a second anteroom. This utility room is where their autoclave, their freezers, and stuff are located. They received this wonderful set of plans. You don't have to see what they are, but they look really nice. So what went wrong? Well, the ventilation design was okay. It was relatively simple, which is good. Then they had biosafety cabinets that they wanted installed. And I'll talk about that in a moment. They had poor execution of the plan. And I didn't want to say they had bad contractors, but I put it politically correct and said lack of experience of the contractors. So again, it's a relatively, you don't have to understand too much. It was relatively simple. It was a one supply system and one exhaust system for the BSL 3. They had Class 2 B2 cabinets. And what does that mean? That means they're hard connected to the biosafety cabinet. So whatever the exhaust fan pulls is what it pulls out of the cabinet. So they had 2 Class 2 A2s on the left in lab number 1, and they had 1 Class 2 B2 on the right, which is lab number 2. They also had some exhaust in the autoclave room or utility room. So here are the Class 2 B2 cabinets. You can see there's not a whole lot of different space above the cabinet between that and the wall, and then it made a 90-degree turn into the duct. Whoop. And the video's not working. There it goes. Now we're going to turn off the fan and watch which way this piece of metal rotates. It's going counterclockwise, right? Now watch this. Which way is the arrow? To the right. What's wrong with this photo or this movie? It was simply they had 2 wires connected backwards. So the fan was going backwards for almost 5 years and nobody noticed it. And then here's the artwork for ductwork. It comes up and makes all kinds of nice angles. So if you buy something by the pound, this is a good deal. If you want to buy it so that you have minimal resistance, this is a bad deal. And these are things where we need people to understand why you want to do stuff. Then we wanted to measure airflow rates. We had to cut a hole in the ceiling to get to the duct because they didn't plan for access to measure. They didn't plan access for us to measure particulates for the biosafety or for the BSC test. So there's no way to test the exhaust filter. So these are things that weren't necessarily in the plan. The contractor had no idea about it, and obviously the consultants that they hired didn't either. But what we did do is we trained local folks. So the local folks now know how to measure ventilation. It may not be super precise, but good enough to understand if it's working properly. And look at these guys, they're all happy. We measured the ventilation with cardboard boxes and a vanometer inside. And we were within 15% of what we did with the flow hood. So you can performance check very simply if something is working properly. And that's why we're trying to build capacity in country. So the solution here is really we need a expertise or a review of a project before it's done. We need to build local capacity. Remember that KISS-A principle. I want to talk about a lower level lab, and that's really a general public health lab. They do smears. I didn't use the term GeneXpert, but essentially that's GeneXpert. Risk is relatively low. Again, this group didn't like to use absolutes. So the conclusion by 2012 is a low-risk lab. By WHO 2004, it'd be 1/2. It's not quite a 1. It's a little more than a 1, but it doesn't have to be a full 2. So take a look at this. Left one's an enclosed space. Right one's an enclosed space because the windows are closed. The door's only open because we were taking a picture. So there's really no ventilation there. And my time is up. See, I told you I said it. But, whoops. So that's one of the work tables. That's where they do the smears. GeneXpert. This is from the CFID website or YouTube video. Most people say, oh, there's no risk at all with GeneXpert. Well, there's one part where you physically shake, or you can use a vortex. And the weakest point, Barry and I were talking about this the other day, is what is the sputum in? A lot of times it's not in a nice, tightly sealed vial. So you might need to do something. And and Chris was involved in this too. CCGLI, Union, and APHL came up with a design for a ventilated workstation. And you'll see in one of the booths, do you see the very top with the whirlybird? It's very simple to use, relatively inexpensive, and with a little bit of wind during the day, you don't need any electricity. You can put a small solar-powered fan in there when you don't have it. So there are lots of things that people can do. The solution here was really just good work practices, effective environmental controls, but simple. That's all. for this union meeting, unfortunately, got held back at the last moment. So we have, I don't want to say the next best because that might be insulting. But we have a very good stand-in for Moses. So, and we'll hear about challenges and solutions to construction, maintenance, and safe TB culture labs.
As introduced by Paul, I will present Moses' presentation. As said by the title, the presentation will look on the perspective of the end users. What is the challenge? What is the solution? The Uganda example proposed. What is the whole process of putting safety and constructing an TB laboratory? We'll go through some slides and see and exchange later if there are questions. From the perspective of Uganda example, biosafety in TB culture lab depend on three main aspects. First, we have to look on the layout of the laboratory facility design. And this have to be done at the beginning. But once it's done and bad done, as explained by first presentation, it will be challenging. We have to look on the safe equipment to be put in place and to look on the practice, the process inside the lab according to the package of activity we like to do. Therefore, the construction and the infrastructure maintenance will be or critical or not critical, depending on the three criteria we say. Let's look on the financial challenge. First of all, the cost should be informed by the architecture design and the bill of the quantity, what we like to do, according to the level of the laboratory we like to introduce. As we are looking on TB lab, the package can be only microscopy and molecular testing, but we can go to moderate or high level. And this will have some implication. Usually, no country have expertise to design and to estimate the cost. Mainly, we have no budget to hire an experiential ventilated people looking on the design and the engineering aspect. We have also experienced that local engineering will provide sometimes grossly underestimated amount without looking because of also lack of expertise. As this is done, it's usually under budgeting, and then it will become very difficult to maintain because all these aspects are not taken in consideration. The cost for construction of a safe and TB culture lab are so high and many times prohibitive. But we have to acknowledge that up to now we receive many funds from partners from different agencies to build some capacity in the continent. One aspect is the prefabricated lab, which can be cheaper, rapid, short-term as solution for countries without TB culture lab. But however, these have limited space and capacity at the country level. Let's look now, I would like to come back to the last financial challenge to say something on the cost. When we look on the cost, as we don't have expertise, the design, the architect will look on the final cost of the building, but they don't take in consideration many times the life cost of the whole building, included equipment. And the challenge will become now on the maintenance of the building and the equipment. And many labs in the African region sometimes close linked to this problem. Let's look on the procurement challenge. To construct a lab, this can take many steps in the procurement process. First, you have to look at the design, the consultant procurement. Secondly, the constructor procurement process itself, and later the certification of the procurement. I will not go through the whole process, but let's look on the challenge we'll face during this process. Each of these is the lengthy process, both at country level or donor level, because of all this information we already explained before on the lack of expertise in the country. Then we will be the expertise sometimes will come outside of the country. And the outcome can be very challenging. And sometimes in many countries, we'll have 5 to 6 years to have a building completed. Usually, all the competencies are few individual and or company. And this will have as an implication, if you hire a company for designing, you have no one to consult to do the implementation. Importation of ventilation equipment. Many of these equipment are coming outside of the continent. And this can be also a challenge on the cost if previously in the plan and the budget, this was not taken into condition in the package. Custom clearance. This is also is very difficult because these goods are not familiar with the process, the regulation, the country level. One solution of this aspect for the African region is to look how we can use our own material in the African continent to minimize the risk of cost, but also this limitation on regulation. Let's look on the construction challenge. Obtaining permission to construct in city is very difficult because of the local condition, but also local regulation. Most, we have high potential also local regulation on, because sometimes laboratories are clean, linked to hospital, or but also sometimes laboratory can be individual. We have limited number of individuals with competency to design and construct the lab. We have few ventilation and engineering in the continent, and we have, for example, now, according to the survey we do with WHO, Afro, we have only less than 5 TB culture labs constructed in the past 10 years. But when you look on the infrastructure in the continent, particularly hotels, we have more than 1,000. It's to show you an example how it's challenging the lab can be compared to other infrastructure. Let's look on the second challenge on construction. Many countries have to repeat or abandon the construction after hiring and even developing a project because of lack of expertise in the continent and engineering. Example of Uganda from Moses is that they canceled the construction of one of the projects, you will see the building later, realizing that they hire an incompetent ventilation engineering. Then they have to wait and begin a single source to justify the procurement process and to have someone on board. And this takes them 2 years. Too many country advisors on construction with conflicting advice. One can be an expert in the continent looking on building, but don't have capacity on medical infrastructure. And this can come at during the process to be confused, and the country can be confused what to receive as product. This is, when we are talking on the construct challenge, we have to look on the design, we have to look on the costing, we have to look on the installation of equipment, like from ventilation to the equipment to be put in the lab according to the different level of the activity we are planning, but we have to look also on the, thank you. We have to look also on the commissioning. Let's look on the maintenance challenge. I will not go to the cycle of the whole process of maintenance because the maintenance, again, go through a procurement process because we don't have capacity in the continent. For TB culture lab, extensive ventilation maintenance is done at least once a year according to the guideline. Challenge, of course, very difficult to sustain maintenance budget because at the beginning of the implementation, this part of the contract was not put in place, and there are no budget for that. Then we will have building, nice building in many facilities, many countries, which become like a white elephant. The challenge also is limited due to company, because we have small company, and these companies are overloaded with requests. Let's look at the maintenance challenge again, but the other side is in planet, and when the challenge comes on breakdown, and this is not an annual maintenance plan as for certification of the equipment. And this also emergency intervention is very difficult due to the lack of capacity at the country level, but also the fact that we don't have enough company in the continent. Then accessibility and turnaround time become very difficult. We have another challenge is the power challenge. Erratic electricity in many facilities, which will affect the functionality of equipment, and lack of costly backup generator and fuel. As you will see in many infrastructure in Africa, where you have nice hotel with all this possibility. Then what some solution we come with? First is before you go for implementation of a laboratory, TB laboratory capacity, according to the WHO guideline, the 2012 is my last slide, I'm sorry. We have to be prepared and to do some field visit, to visit labs who are very well functional, to understand how it works and what can be the lesson we can take from them. Secondly, we have to use people with proven competency in designing and construction and maintenance. Then the all three package of what we say at the beginning will be taken in consideration. As TB culture lab increase, the demand is now, the last WHO release recommendation where we have to improve the capacity of second-line drug testing using LPA or culture, we have to begin to look on that, and this may be a room to increase the pool of competency in the continent, particularly engineering and capacity on training. The second part of solution, we think that in Africa, TB culture lab design should have the following attribute or requirement. First, robust to minimize frequent breakdown. But this, again, will be linked to how you develop your plan and what capacity you have. Limit accessory to those that are vital. What we mean? We mean that when we are talking on lab, this is an example of TB lab, but this applies to every high-level lab which we are using special techniques or special tests. We have to look for each country should have more than one TB culture lab, like from public sector and a government or private sector, to be sure that we have backup and good collaboration between them. We have to secure a budget for maintenance and have maintenance contract well defined in advance when the plan and the project is developed, particularly in ventilation of equipment, generators, and safety equipment like safety cabinet, centrifuge. I would like to say that on behalf of Joseph Moloba, Uganda succeeded after some years to achieve this new building, which will be the new TB SRL lab in Uganda. Then difficult it is, but it's possible to come to a concrete and functional TB lab. On behalf of Joseph Joloba, hi, and thank you.
In case you don't know, that's him on the right.
Thank you. I would like to introduce Serley. Serley is a specialist from US. He have a company called Germ-Free Laboratory Company, which is specialized on ventilation program and process. Thank you, Jeff.
You're welcome, and thanks for having me. So I'm going to kind of echo a lot of the things that they've said, but I'm going to take it down to a more micro level and focus on the primary containment aspects. I have no conflict of interest. So I've been talking to a lot of people this week and everywhere I go, and a lot of times I hear I must have a class 2 type B2 biological safety cabinet because that's the safest one to use. So does anybody here agree with that statement? Is that a fact or is that a myth? Well, I'm here to tell you that's a myth. It's not the safest type of biosafety cabinet, and sometimes it can be just the opposite. And maybe you've heard that, but let's talk about why. Number one, the guidelines out there tell us so. So if you see here the definition from the CDC guidelines talks about open-fronted class 1s and class 2 are primary barriers. The class 2 biosafety cabinet also provides protection from external contamination, so you can do your cell culture work. But it doesn't differentiate between class, type A, type B. It doesn't say type B is more safe. It says they all have that same capacity. If you look at the TB guidelines, it says that, and I didn't make this up, this is from black and white, this is the preferred type of BSC when they're talking about the class 2 type A2. But even though it's written down, maybe it's good to understand why. So to try and talk about why, here's the airflow diagrams of a class 1, a class 2 type A2, and a class 2 type B2. Can you tell them apart? I mean, if you look at them for a few minutes and study them, you probably can. So the class 1's on the left, class 2 type A2 in the middle, and the class 2 type B2's on the right. Okay, so you see what's happening inside. That makes it a little bit easier, but what if you look at these pictures? Can anybody tell which is which from these pictures? Anybody want to guess? So I mixed them up to make it interesting. The class 1 is on the right, and the class B2 is on the left, but they look exactly the same. They all have that open front. And really, what's protecting us? If you look at all three of these cabinets, this part I've circled here is the same. They all have that directional airflow pulling the air away from us, containing things. So the reason the B2 is not the best choice, so there's a couple reasons. Number one is a little bit more complex. The class 1 and the class 2 A2 are pretty much self-contained. They don't rely on any engineering controls from the facility, where the B2 doesn't operate if the building exhaust system's not operating. And I can tell you, I manufacture these. If you leave off one wire, there'll be no alarms, there'll be no indications it's not working. You'll walk up to it and think it's working just fine, and it's not. So, so they're more complex, they require more maintenance, they require to be checked more frequently. So this is why the class 2 type A2. People often say, well, the B2 is safer because it's 100% exhaust. Well, what they're talking about there is they're talking about inside the cabinet. That's what's happening in here is 100% exhaust. What comes out of the cabinet can still be 100% exhausted in the B2. It can be 100% exhausted in the A2. It could be 100% exhausted in the class 1, and it frequently is. So the key is you want the simplest piece of containment equipment you can get for what you're doing. You don't want to over-design it. Another one, more engineering controls are going to make me safer. Anybody agree with this? Well, I don't know who these people are, but I guarantee you this guy doesn't feel as safe as he could if he was just doing a smear. He'd much rather be without that big suit on, without the air blowing in his ears, without the cold air flowing over his body. And this guy's probably not super happy either if he's doing a slide smear, because he's working through gloves, his movement's restricted. Now, that's not to say there's not applications for this type of containment and this type of primary engineering controls, but I don't think that's appropriate for a TB lab. So we'll call that one a myth also. So what do I need in the TB lab? If you're doing just smear microscopy, this picture is of the ventilated workstation. I think we've all seen that. Paul talked about that a bit. It's a very simple negative airflow. It's a step actually below a class 1 even. But from the operator point of view, it's as safe as any piece of equipment you have, because it draws any aerosols you create away from you and takes them out of the building. Now, this could be a class 1. Adding a HEPA filter would be a class 1. So that just gives you an idea of how that airflow works. And if you're doing culture work or any molecular work, you want the class 2 A2, and you'll have to take my word for it, that is a class 2 type A2. So now we talk about the maintenance. Again, the more complex your engineering controls are, the more maintenance they're going to require. I'm not a fan of the traditional guidelines that say the safety cabinet must be tested very frequently every year. I actually feel like if it's built well and it's a quality cabinet, it can last much longer than a year before it has to be retested. But it needs to be tested at startup. You need to verify that once it's in place, it's working fine. But then there's also daily operational maintenance. And then again, the annual certification, we can probably negotiate about that. We can talk about that later. But I think that to really understand what maintenance is required, just a couple slides on what the cabinets are doing for you. This is talking about a biosafety cabinet, Class 2 Type A. There's really three things it does for you. This is showing the manufacturer's test. Not that this is what we do in the factory, but it's showing how they're testing the factory. This is an arm simulated going in the front window, and then they're creating a aerosol inside the cabinet, and they measure for it outside. So that's protecting the person. That's that inward airflow. This is showing an aerosol be created outside the cabinet, and then culture discs sit up inside the cabinet to make sure your product's protected. Your cultures aren't getting contaminated with room air. But very importantly, we'll expand on this in a minute, this is a cross-contamination test. And maybe a lot of people don't realize what you do on the left side of your biosafety cabinet should be segregated from what you do on the right. The biosafety cabinet protects that cross-contamination as well. And that'll really tie into the operational maintenance. So to know all this is working, what do you need to know from a maintenance or a certification aspect? You need to know your filters are good. This is a picture of a gentleman doing what they call a HEPA filter leak test or a DOP test. He's assuring the filter doesn't leak, that the filter is seated well in its gaskets, it hasn't shifted. I think this is important when it gets installed. But once it gets installed, this is not going to change. The filters don't spontaneously start leaking unless something damages them for a long time. And then to make sure you have that containment, you need to know what the air is doing inside the cabinet. So you measure the air coming down, and you see he's got his little velocity meter there, and this guy's measuring the air coming in the front of the cabinet. If you measure these two parameters, you have a pretty good idea it's doing what it does when the manufacturer tested it. And that's really the goal, is to make sure it stays the same. But every cabinet has a gauge on it. And if that gauge doesn't change, it's pretty certain these airflows aren't changing. So this is something that really you may not have to do every year. If your cabinet's really working, it's tested when it's there, it shouldn't stop working. Oops. And then there's a bunch of secondary tests about the site. If your cabinet's exhausted out of the building, you want to make sure that exhaust system's working. This is a shot of a canopy connection on an A2. The real beauty of an A2 is even if you exhaust it so no air comes back in the lab, if the building fails, the air will still recirculate back into the lab, but it's HEPA filtered, so you still have that protection. And then there's a lot of secondary tests, the noise, lighting, vibration, tests like that. Those aren't really as important unless you use it as a daily test. If you feel the cabinet vibrating during your operation during the day, that's an indication something's going wrong. Maybe a paper towel's gotten sucked up in the blower, but from a certification test, it's not as critical. Airflow visualization. If I had to work in a biosafety cabinet and I don't, and I was allowed to do one test, it would be this. This lets you see what's going on. And if you went back to those airflow diagrams and you saw and you understand how they're supposed to work, smoke is the safest test out that really tells you what's going on. And the other reason I really like this test from an operational point of view, to test the HEPA filters, you might need $7,000 or $10,000 worth of equipment, and you might need to know how to use it. To test the airflow, you need probably another $7,000 or $10,000 worth of equipment, and again, some training and maintenance of your equipment. The equipment itself requires annual calibration, so if you have just one or two hoods, you really, you don't need to do all that. But if you have a smoke source, you can buy a professional smoke tube for $350. So big difference in cost. You could also have another, a cigarette is what they used to use 25 years ago, but you see what's going on anyway. So daily operational maintenance, I think, is really the key from an operational point of view. I mentioned the cross-contamination. You want to keep your work area neat. Have the clean equipment on one side and work towards the dirty side. The cabinet will protect you from all that stuff being moved back and forth, and it'll keep your clean cultures from becoming dirty. Very important. Housekeeping, understanding how the cabinet works. So obviously, these people didn't set this up nice and neat left to right. They've got their clipboard over the front cabinet. These guys have their, I guess it's a pipetting wand over the front grill. All those things block that airflow. You don't get the protection you think you have. Those are the things I would tell you are really important from a maintenance point of view. If you get to a ventilated workstation or or class 1, it's less important. All you have to do is make sure the air is moving in. There's a company downstairs that has a little meter. I believe that's free. If you set that in the front, that tells you have your protection. That's all you need to do. And as Paul mentioned, there's even ways we're looking at now. You can even get the airflow moving for free. So key points, class 2A2 is the correct cabinet about 99% of the time. There is a call for a class 2 type B2 unit, but it's not in the TB lab. You're just making things more complicated and likely not working well. Use the proper engineering controls. Don't just put in the most you can get. If you're only doing microscopy, use a ventilated workstation. Don't make it more complicated on yourself. And then the proper use. You don't see anybody wearing the face mask where they don't cover their nose. That's the same thing as putting your clipboard in the front of the biosafety cabinet. Just don't bother. Don't just work on the bench. So that's my presentation. Thank you.
Thank you, Jeff. Our last presenter is Grigory Volchenkov, who's the TB doctor for Vladimir Oblast and has been all over Eastern Europe consulting and other places, and he's going to talk about evolution of the TB lab in Vladimir Oblast, Russia.
Thank you, Paul, for introduction. I have no conflicts of interest, but no slides about that. So I will tell you about the development of the TB laboratories in the region of Russia, and this is just one of the regions of Russia. Total is 90 regions, and this one is located in the western part of Russia, and I will tell the history. So the smaller picture shows the older location building, and we actually left in 2002. So this is a prehistorical time for us, and at that TB hospital we had a lab, high-risk lab, performing solid cultures and microscopy in the space which were not actually well designed and served well for these purposes. So 14 years ago we moved to the new building. This is five-story building, former children's hospital, was not designed for TB or for laboratories, so we actually thought that we have to organize good lab. We understood at that time that good TB lab and safe lab is critical for TB control for the region. Without this lab, the hospital is not safe, patients are not safe, and we cannot provide good control. So, in this building, we dedicated first floor for the TB laboratory, the best space available actually in the building. And this building has double-loaded corridors in the center, so this is the ventilation design plan for this laboratory. And in the very beginning, we decided to install ventilation systems in the highest risk zones of the building, including lab, smear-positive floors, bronchoscopy units, and so on. So we decided to have 2 zones in the laboratory, high-risk zone and in yellow, and low-risk zone in blue. And we put the airlock between them, and we have 2 dedicated entrances into the both zones. But what's important to mention that the first actually occupational TB cases occurred in this building and just on the next space to the laboratory, in the administrative space. In the very beginning, we didn't have a ventilation and we didn't have seal entrances. So the first cases of occupational TB were related to the TB, but for not TB staff. So TB workers already use biosafety cabinets and personal protective equipment, but because of the air passively moved from the high-risk zone to the administration, so we actually had some cases of TB. So we did the conclusion and installed the ventilation system, and the lab actually became more safe and effective. So in these 3 years, we did the centralization of the services. Actually, we closed culture points, smaller culture points, and smaller laboratories in the region, and started to do the cultures only in this laboratory. So we also centralize the microscopy from 146 labs into 22 microscopy centers equipped with the class 1 biosafety cabinets. Also organize logistics and transportation of samples into this microscopy centers and TB lab, and improved biosafety, reduced costs, and improved quality assurance of these laboratories. So starting 2006, we started to use liquid media, bactec culture, and we did the validation and started to actually use all the good features it provides for good treatment for the patients. In 2012, we started to use GeneXpert machines. In total, we have 5 machines which are located in Central Hospital and in 3 smaller catchment laboratories. And we organized also the transportation system for this GeneXpert technology. And also we have an IT-based, web-based system to have an instant messaging about the results of the laboratory to follow up the results and treatment initiation. So just a year ago, we did the renovation of this TB laboratory, so it became look better after that. And also they installed the safe closing devices, they fixed the ventilation system, and relocated some services in the laboratory. So we also implemented the diagnostic algorithm, which includes sphere microscopy and rapid molecular testing for all TB suspects for the region. So we are able now to actually implement the fast strategy to test every suspect and start treatment immediately for drug-resistant TB, susceptible TB, and also correct the treatment protocols according to the liquid and solid culture DST in the region. So I like very much the WHO manual Chris just presented to us, and it's actually more realistic, more based on the reality in the field. And we implemented lots of actually features required for the laboratory based on the risk for the. So it includes upper room UVGI, 6 ACH, mechanical ventilation, this building, biosafety equipment, PPE, and so on. So if you'll take the older WHO 2003 manual, you can see that some BSL-3 features are not in place in the laboratory, but I believe they are not that critical. For example, room sealable for decontamination is not available. And also HEPA filtered exhaust is replaced by the HEPA UVGI decontaminated, disinfected exhaust in the laboratory. So also we have no showers in the laboratory, and also what's double-ended autoclave is not, we have no such. But we do have biosafety equipment like BSC class A type A2. Absolutely agree with the previous presenter about the B2s in such laboratories. So they are maintained, and 4 of them work perfectly in the laboratory. So in 2008 and 2009, we started actually disseminated of the biosafety experience and skills, and together with Paul Johnson and CDC and Eagleson Institute from United States, on the basis of our lab, we started to organize the lab biosafety courses and also BSc certification and maintenance courses for engineers from Russia and Eastern Europe and Central Asia. So what's the outcome? Because of these developments, we actually reduced the cost, reduced the volume of the laboratory tests, and improve the quality, and also we were able to implement fast strategy, which is extremely important to make safe hospitals and more effective treatment for the patients. And also we have 0 TB cases among laboratory staff since 2002. What's next steps for us? We still lack rapid molecular test for second-line drugs resistance. And the bad news now that I learned that the GeneXpert are not able to actually deliver this test next year, and even 2018 is questionable. But for us, with a quite actually important problem with second-line drug resistance. It's really challenging. Also, the BSc maintenance and certification is still a problem for the region. Actually, the many regions and countries of my part of the world experience problems with the maintenance of cabinets. And also, we plan actually to help penitentiary services in my part of Russia to provide quality assured and safe laboratories testing in our laboratory. That's all. Am I good in time?
You're
Paul?
the only one.
Thank you.
Okay, what we'd like to do is, we'll go ahead and bring all the speakers up here. Chris, Jeff? Yep. Just grab one of Sharon's. And, you know, I think it's, you have no choice now because everybody's given their talk. But we thought it'd be better after the talks to be able to ask questions. That way, you know, we might be able to bounce them off each other or have an argument or something like that. So any questions or comments? And you'll need to use the microphone because they're recording the session. Please.
My question is for Chris. I will recall, as many people do here, that it took a long time to get those TB biosafety guidelines passed, and I do approve of them, and I think they're really very useful, as most people do. But during this conference, we've heard in various meetings and workshops that there's a move to bring services nearer to the patient, and you and I were sitting at sessions together where we heard about level 0, level 1 particularly, and it was more geared towards the patient and the clinician. There were no sort of technical laboratory people involved in those discussions, and I'm wondering how you feel about what the implications would be for biosafety if we move the technologies further to the lower level of the health system as is being proposed.
Questions up?
Yep, you're done.
I'm done.
Chris, you want to start?
Yeah, okay. So yes, so this is, you know, really looking at patient pathways as a way to improve the diagnosis of, or be able to diagnose more patients early. And so, you know, some of the understanding patient pathways, you need to know where they're entering the health system, at what level, and considerations for whether you actually have diagnostics available at that level or you actually have referral mechanisms. So, you know, I think the challenge of biosafety, moving that to very low levels is probably problematic, and it's a balance that you have to establish. Either refer samples and not think that you can do everything at a very simple health post, and where it can be implemented, all well and good. Where it can't.
Yeah, and I think based on the risk assessment that you were talking about earlier, you know, I think that GeneXpert, the smear microscopy, assuming it's still going to be around for a number of years, you know, can be done at near, you know, the patient. The goal really is to have, you know, the what's necessary for biosafety at every lab. So I mean, I don't think it's really going to be that big of an issue at the health center type lab to deal with some of this issue. Anything else from the panel on that?
May I react to this?
Huh?
May I react to this?
Yeah, actually, Barry wanted to react first. You'll be second, then we'll go to the next question. Microphone, please.
I think you said most of what I was going to say is that the technologies, when they're talking about moving closer to the patient, they're things like GeneXpert, they're molecular tests that are low risk tests. They're not talking about moving culture to the you know.
They are talking about, the whole focus was on the patients, which I agree with, but there wasn't a discussion, practical discussion of how it would be implemented from our perspective, providing the diagnostics. That's why I brought it up.
Okay, no, that's fine.
I just think there'll be simple, you know, again, simple tests that are low risk.
And would not be part of your risk assessment the number of samples which will be lower the lower you go in a way? If you would the community testing when with Omni, for example, that will be very low volume?
So, Yeah, well, the Omni is being developed as a point of care instrument that would be used in settings where microscopy currently is being performed. It still is, you know, we're talking about level 0, which is a very primitive health post where the only sort of, you know, clinical support would be asking questions about your symptoms and then making a decision whether you needed to be referred for a particular test or not. So I don't think we're talking about moving even the Omni to this very lowest level, but maybe to refine the education of patients, of healthcare workers that are encountering patients for the first time, to actually check for their symptoms, to say, well, here is a request for a chest X-ray screen, or here is a referral for an Omni test or GeneXpert test on the Omni.
Okay, and then Elaine and Chris and I were talking about a session for next year, and we had low risk, but we'll add the quote unquote level 0. We'll call it something else, but we'll add that too so that it's addressed next year. Yes, Kathleen.
So there's two people I want to ask questions to, or make some
Just one at a time. It'll be quick.
Okay, so you talk about risk assessments. So I go into countries and I talk about risk assessments in my lab, and they have no idea what I'm talking about. Is there any way we can start some training of facilities how to do a risk assessment of their lab? We don't have that, and many people don't know where to start. The other one is for you on the cabinets. You said quality cabinets. That's key, because I go into countries and I get cabinets that are from some country, I won't say, that are horrible. And they need that certification test annually. They get clogged filters, things happen. So I'm not about the annual certifications. I think we still need them because some of these countries are not getting quality cabinets. We want them to get quality cabinets, believe me.
Absolutely.
But that's not what's happening in reality.
Well, I agree.
Anyway.
So, I agree with your risk assessment question. There are a series of different checklists, but I don't think any one really addresses that issue, and maybe that's something that we can raise with GLI.
Just in the biosafety manual, there is a section or a box. How do you conduct a risk assessment?
And that's what I go through.
Yeah.
Yeah.
So it's
That's
not
the starting point,
it's a summary of the various steps without going into detail. But
We just need we need to do it with them. That's the part. TAs and the technicals, we need to have that kind of program when we go into do that technical assistance, where we walk through those steps with them at least once.
yeah, sure.
And they need to do it annually because things change and you get a new supervisor in that doesn't tell there's issues.
No, definitely.
And as not being a manufacturer, to make a comment about your cabinet issue, places that I've worked, what we're trying to encourage is countries to adopt, I don't care which standard, but adopt a standard for the country. It could be an Australian standard, European standard, the NSF 49 standard. Everybody will tell you theirs is better, but to me, something is better than nothing, so that there's at least some minimum bar. So as you talk to your different countries, I think that should be a topic at the national level is, let's talk about getting some kind of a starting point for cabinets. Yes, sir.
Thank you very much. So I have a question for everybody, basically, and some suggestion as well. So I think we are facing really issues at the country level. I need practice. So let's say after this meeting, what can be the message? If I go back tomorrow to my country and I need to set up a biosafety, I have problem. Why do I have problem? Is that we have many guidelines. They are really well written. But when you go down really at country level, they lack this kind of, like what we were saying, risk assessment. It's well described in our guideline, very well done. But I think there is a lack of translating, let's say, any recommendation we have to something which is practical at the ground. At country level, biosafety is something they don't understand very well. That's a problem. Even if countries start to design the labs, you mentioned that, Alain, in Moses' presentation, some challenges related to lab design and layout and so on. we are end up with the buildings which do not even have enough plugs. You know, if you plan to have 5, 10 machines into the lab, you cannot even walk inside. And also there is this lack of communication in between the end users, the lab personnel, and the designers. It's a nightmare. So I think we should go really let's say beyond the guidelines and come out. I think there's, Chris, we discussed this. This may be the role of Global Laboratory Initiative for Africa or Global Laboratory Initiative per se, to really to come out with a useful document. Let's say even a checkout. From where can we start? Do we start by risk assessment? Yes, if we do, we have to be part of this risk assessment. The architect, the builder, the lab personnel, how those people can sit together and talk before even the work can start. I think this is what we are lacking. Types of biosafety cabinets, we have them in the books, many. But when you go to the site, you even found biosafety cabinet you cannot even install because they lack quality and the specifications are not well thought, etc. So personally, in my perspective, that's what I think, because I'm on the field, I have the challenges all the time. If I have to do something now, I would prefer even, I am a pro this prefabricated lab because I found this as a solution for our settings in Africa. And also I would prefer one-stop shop that has everything inside. Because we have noticed that even if you have separate specifications for the lab equipment, then you build the lab. At the end, even the door is so narrow that the equipment cannot even go through. Or you order the equipment from UK and the plugs are from France, you cannot even plug, all the equipment inside. So I think we need something that can be well understood. Yeah.
That's good. Please, first reaction.
Is it a reaction and something going after the GLI Africa meeting in Uganda? There are some suggestions coming from participants and some organization. First, as highlighted by Kathleen, when you go to the Center of Excellence we build in Africa, this is in Rwanda, this is in Akilt in South Africa, when you go to the content of training, safety issues are taken in consideration, but it's like 1 or 2 slides. We don't have a clear component of safety issue. Then we are delivering certificate to participants who will go to implement culture, will go to do LPA testing, but they don't have the requirement to understand how to do safety. I think these have to be the first advocacy. We have center in the region which can provide training, how we can build capacity locally to have this kind of knowledge sharing at this facility. Secondly, I think at the second level is GLI level. GLI global or GLI on the region and Africa particularly. During our last discussion, we said that why not to use the same channel we have existing in the, to do a one-shop center, what we say. And at the GLI, we are thinking, we are already beginning to draft something as a book for the layout of lab. And these books will have all these 3 steps as presented, probably nice, not too nicely, it have to be improved. The 3-step, design, engineering, equipment, and maintenance. Then this will help the one-shop center, TB manager, NTP manager, lab manager, and stakeholders, donors, to have something which they can use for implementation. Because when intervention come, I'm USAID or MSH, I would like to support a lab, I will come with what I have money. But when it comes to implementation, is the lab in the country level, scat different departments who will go to South Africa or Uganda and take skills. Then there are no, as is present, one group who can take different component of, because we don't have all of the skills in one people. Then I think this kind of guideline or books, but also again, it will not work because the safety manual is clear, is good, but it's how to translate and who translate and who implement. This is what is missing in the pipeline.
So, and this is exactly the sort of implementation guidance we've been discussing with a number of partners this week, that really to give some practical examples of the type of ventilation systems you may need in certain environments and what the options would be for the types of testing that you're going to do. And so working with some of the companies as well as partners, we will, as WHO, start this process as well. So hopefully in the next 12 months we would have some guidance similar to that available.
Yeah, I come back to what Jean Didier say. I think guideline is fine, but translate in the field by knowledge, people who have to take this guideline and help the country to implement, like what we see in Russia, because CDC go there and help them to translate the guideline on implementation. Then we have to build a pool of people to help the translation of this guide. And these people have to be also trained and to understand what has to be done.
Jeff or Gregory, you have anything to add? Okay. Just one quick comment, and that's one thing we also need to think about, because maintenance was raised, which is very important. What we just did in purchasing some UV fixtures is we required the folks to purchase the fixtures with 5 years of maintenance, including all the supplies, lamps, ballasts, and everything else. So I think perhaps as a newer model, and GDF will do it for equipment that we're starting to add to the GDF list, is allow people to purchase maintenance. And this way, it won't help forever, but at least instead of just the first year, you'll get it for the 5 years. And this would be biosafety cabinets, modular labs, microscopes, it should be everything.
So I was going to say that most of us are doing the same tests. We're doing culture, we're doing DST, we're doing expert. And so there's standardization. We've developed standard methods to do that. But yet when it comes to laboratories, everyone is recreating the wheel. They're starting from scratch, spending too much money, too much time, and getting poor results. So you come up with, instead of each project being unique and having to develop something that fits in a particular spot, develop a standard solution that can be applied anywhere. And I use the analogy of a car. I tell people, do you have a car custom made for you? Some people might, but no, Toyota, Mercedes, they've worked out how to build these things efficiently and give you what you need. So you go to them. We don't design our own centrifuges. We don't build our own biosafety cabinets. Why should we be starting from scratch every time we want to build a lab? And then the other thing is getting towards what Dr. Hollande said about maybe standardization, that if you're in a developing country and you need to have 10 labs, do you want each lab to be unique? Every time you need a part, you have no standard supply to go to. If your labs are at least somewhat standardized, you go and you have those parts, you have the knowledge on how to repair them. Each one, it's not like driving a strange car that no one has ever seen before and say, please fix my car. And the mechanic says, I'm sorry, I don't have parts, I've never seen this before. So I think standardization. Then finally, I just want to talk about maintenance, that I can say now after 7 years of experience with the modular labs, that the costs of the modular labs, at least some designs, are at least 50% less than in the standard TB labs. And we've really had very few problems.
I'm Dr. Vishnu from India. I was the administrator for the first BSL-3 at state level IRL laboratory in Andhra Pradesh in India. This is only a comment. I was behind the development of some BSL-3s in other states in India also. We can have a good cabinets, we can have good in place, we get a good certification. But KF is going to make a very big difference, knowledge, attitude, and practice. It is a very difficult to monitor technical people inside the laboratory to practice regularly. And couple of people who worked with me, even a microbiologist, developed a DRTB. Because we are thinking more and more about the technically equipment, giving a best laboratory to the people, but how they are going to use it makes a very big difference. That is the area we have to focus. In addition to the yearly annual screening test, I feel personally it is better to counseling each technician that is very, very badly required to prevent a TB in laboratory staff. Thank you very much.
Any reaction to that? I've got one reaction, and that's, I agree 100%. In one of the slides, it talked about SOPs and work practices first. So I agree 1,000%. And the first labs that I went into 20-some years ago, they did culturing and stuff on the bench. They had lower contamination rates in many labs working on the bench than what they get now working in a biosafety cabinet. And it's all because, in my mind, because of work practices and people thinking, oh, I hear this cabinet running, it's safe, I can just do whatever I want. So you're absolutely right, we have to emphasize work practices. Microphone, please.
Contamination rates are within permitted limits, not the development of a disease in the technicians. Though the contamination in the cultures is normal limits, but the infections in the people are going beyond the limits. Thank you.
Kathleen?
Last comment.
That's
So
fine.
what you talk about, one thing about risk assessment that I think that is important to remember is susceptibility, resistance, and the different resistant types. So when you have a susceptible strain, an MDR strain, and an XDR strain, I think the risk is going up and up and up. So we can't forget that when our staff is working with it. The other thing is about the biosafety cabinets. You don't know how many countries I've been to, they don't even know how to clean one. They've never lifted it up and cleaned underneath, and it's just horrendous. That's clogging filters. Nobody trains them when they install those cabinets, the maintenance required to maintain them on a routine working schedule. So that's another thing that needs to be implemented in this guidance is some of this maintenance equipment that's routine.
I just had a reaction. I think that what's missing is sometimes when you save money on the initial purchase, you're not thinking long-term, and I know finances are always tight, but that's a message to take home, is that if you buy the cheapest thing, you get the cheapest thing, so, yeah.
Thank you very much. So, sorry, just I came at the last moment, but I have some question in my mind. I think the challenges should be the same like all folks here. In Bangladesh, I'm a TB Lab Advisor Challenge TB Bangladesh project. So the biosafety is a major issue, like the cultural and reference laboratory, if I say this specifically. Because in what I saw in the first, maybe after 6 years, we got the cabinet certification. You see the 6 year, there was nothing. And then first certification, then we started the project, we had contracted the FMS, and it takes years to get the service there. And we saw that some of the biosafety cabinet even is not eligible for working, but staff are working there. The problem is the country level expertise we don't have. The regional level we don't have. And the maintenance is such a precious things to have someone on board and get the things done. So we will provide, we know the training is needed, but we will provide the training. What are the spare parts and equipment? Because some of the biosafety cabinet, they are manufactured from the is old biosafety cabinet, and getting their HEPA filter is not a easy thing. So this is actually the real challenges we are facing. So I think we need a regional level, some connectivity, and even from the planning procurement level, the program need to think so which are manufacturer are available to provide the success, who have their service center in the country. Then we have to approach this way. And this is a really shocking thing. And regarding the modular laboratory, I think, yeah, it's working in African settings and many countries is good. In Bangladesh, we just, September, we got our first unit, but it was a 4 years struggle. And through the manufacturer, South Africa, shipment, customs clearance, I had to run the ministry different type, 300,000 tax incurred. That had to pay by the government. So you know how much negotiation you have to do with the government. So that's a good that we got the first unit. So I think soon it will be operationalized. But my first thing would be that we have some knowledge, but at the laboratory level, they have very few knowledge, no training, no equipment, no weapons. So I know this is a risk, but I am forced to do work with this such a situation. Because the lab staff doesn't perform, leave the job. We don't need you, we need the service. So this is the management. So this is actually we need to do something for this thing. So thank you very much.
Any comments from anyone? Please.
I think because probably you come later, some of these issues was highlighted in one of the presentation of Uganda example. I think the problem we have is that when we are bringing the project, we don't have the full picture of what will be required when we have the end product, the lab functional. Then is peace coming according to different intervener, donors, implementers. Then at the end, when the Minister of Health of the country host the building, they don't know how to run the building. And because they was not involved in the process, even when they own the building, they don't have fund to sustain the process. Then what we are saying during this discussion is to begin to think at the country level when we are doing global fund proposal to be sure that all these components of the infrastructure and TB lab functionality is taken in consideration. But again, when you come to some setting like the example of Uganda and the continent, the African continent, we don't have this capacity because they are not skilled people. There are some individuality, you can know which machine to bring, but you don't have the engineering, for example, skills. Then you have to bring these people at the table. And one of the proposal, the approach we have in GLI is to develop a kind of handbook which will bring all these three components. And then the question is how to bring these all the information guideline, like the safety manual, and to implement and train people to understand how to use them.
Thank you. Just I will add on things. So this is good that global fund, the other donor, the basic requirement need to be incorporated and should be emphasized or advocacy with the government so that they incorporate this thing. But the reality is that no laboratory was not built in purpose, it just renovated. It's an old building, dilapidated building renovated. And recently, if I am correct, Global Fund, USA, they stopped all kind of renovation and the structural support. So it is the government, so they are making the building as per their own code, own flavor. So this is a very difficult thing to control them and to change the layout. And because I saw some of the renovated building is like a kitchen. It's just like a kitchen, then we did some advocacy, do it, make a separation, do this way, this way. This is how much we can do. But in that case, Global Fund and other donor, if we don't want to play the role, but this structural thing they need to consider in their funding process. So thank you very much.
Yeah, and just one other comment, you had talked about biosafety cabinets and testing them and stuff. I'm working with another group to come up with, it's not really an alternative test, but it's a test that just about every laboratory can do. It's sort of a performance check. And so before you pay the bill for your cheapo cabinet or your high quality cabinet, there's some simple tests you can do with culture plates, with smoke. Jeff mentioned smoke. And if it passed those tests, then it's not assurance that it's working 100%, but at least you have a little confidence. And if it fails those tests, full stop. Because we want to stop the poor performing, I'm going to put in quotations, cabinets from getting out there.
Paul,
Please.
yes. I'll just make one more comment on that. In that, we're looking for expertise within our laboratory network, so the hospital type networks, and it seems to be lacking in many countries. But we have universities in every country. We have research institutes in every country. And so maybe we still need to be looking for this engineering expertise out of just hospital-based services, and even in some sort of pharmaceutical industry and manufacturing, because there must be some expertise available that it will come at a cost. But instead of looking for out-of-country solutions, see what are the alternate in-country solutions that could maybe be more cost-effective in the long run.
Thank you. We officially have 1 minute left, but we're going to stay here as long as they let us. So please.
That's a good. I just have a very short thing. I think I'm very happy also that this session is happening, because as a technical consultant from KNCV, we are struggling a lot, because we get all these questions from countries and saying, we need to do something on this reference lab, and especially Malawi is a very good example here. But one thing I wanted to mention, because you said about practical things to bring back to the lab for people to do and to show, for themselves what are they doing in this biosafety cabinets. And one thing I'm not sure if you have thought about is that you can use Rodak plates, to check how much bacteria are really escaping from your cabinet. I think because what is really important, as we say, is training for the people that are working in the cabinets. I think if you can contain it and you have them well trained, it really will help a lot. And I think that would be really nice if we can get that protocol a bit more worked out, so that each country at least does this like once or twice a year, for their staff to visualize what is really happening in the cabinet, how, you just stamp everything that is in your surroundings. You use those plates also when you do your work, and you show them what is really happening. And smoke tests are really great, but it doesn't really show you exactly, this bacteria is there on your lab coat, or it's there on the door handle, or it's there on your racks when you don't spray them properly. So I think that is also something we need to take into consideration when we're working on a protocol.
That's part of this performance check I was mentioning, but I think that's great.
To bring it back to practical.
Any comments?
I would just say, even beyond that, from a practical solution on a biosafety cabinet, if people are just trained to work in the back half of the work area, you have a greater chance of success, even on a not great cabinet. So.
They're recording it.
Yes, that's good. No, because I know that's what I notice, when I come into countries, I see that they're overloading the cabinets. You see all this they have not trained. And as we're going to think about the kind of training package for these people, I think we also need to get a kind of protocol there that give them some practice, something that they need to do, like EQA. You do in the, you do EQA. You also do an EQA on your biosafety level, which could be easily done by these Rodak plates and having a system for that. Yeah, and so that they also see really what they do and how mistakes they make, and they learn a lot from that. I can tell you. Yeah.
Thank you, Sean.
Hello, I'm Sean Toney with the CDC in Atlanta, Georgia. I have a comment I think that could possibly book in this session or something for consideration. So we've gone through or talked about biosafety and infection control within the TB laboratory, but I think there's one component that was that I think we should also consider possibly for next year's session, which is the disposal of the infectious material. Again, we've talked about everything that sort of happens within the laboratory, but what happens to the waste once you're finished with it? Because in my experiences as well, typically it's sort of taken or walked outside of the laboratory to some type of common area. And then that also creates infection control issues. Sometimes they're in public areas. I was just on a site not too long ago in the same barrel where they were burning the laboratory waste. There was also food there. There was also people walking back and forth. So I think that part also has to be included with this right here as well, so that we can actually break that chain of transmission as well too.
Very good, thank you. Any other questions or comments? Please.
I'm Willie Sengover from Uganda. My concern was we have this biosafety. I've been involved in maintaining a biosafety lab, level 3, for 8 years now. But the challenges we have is that we might be having the technical knowledge, We have the checks, we have the indicators, but I give an example, like if I'm a patient and you give me the glucose test machine, you give me I want to know at what level would I seek for a consultant? At this point, can I go for a nurse? Can I go for get first aid? So I'm requesting, is there a way we can train people to start with at local level to check the biosafety cabinet, to train people how to replace the light? Because now, like, as I'm speaking, the light can get off in the biosafety cabinet, and even the local people, the local engineers, they can't even help you to fix this light. They can't help you to bring back this socket. Before I invite a consultant from South Africa, can we have the training, the human resource, like to start with, to fix the simple things that can make the work stop? Because you can stop working because of a small thing, and yet we can afford to have this training, basic trainings, and we have people who can fix these small things at the country levels so that work can go on.
Your question is very pertinent, but I want to mention an initiative we have in a project in Zambia where they have trained worked with the companies and to train the engineers, the local biomedical engineers who have never been trained in doing lab maintenance, to do very simple things. How to change the bulbs, how to change the fuses, how to do simple things. So they've been trained and it's being sort of monitored as to how they would do that. Now, I don't quite know how it's going to work, but we had biomedical engineers who couldn't do anything, so they had to come from South Africa. That obviously isn't very suitable. So now there's this initiative that's part of a project that they're looking at to see if that can happen. So it's possible that if that worked, it could be a model for other countries to take that on. It isn't yet to do a full service of electronic equipment because companies like to be able to keep that themselves. They don't want to let out the sort of what's peculiar to the company. But basic stuff could be done if you can train your biomedical engineers. But when they do their courses in country, there's nothing that teaches them how to do that. They can't do the autoclave, they can't replace a bulb or a fuse in a microscope, they can't do whatever. So there's a lot they could do if they were trained, and I would advocate that we look into that.
My request was that we should have a group like this to spearhead this, to set standards, like in quality assessments, like in Africa, we have the East African Public Health Surveillance Network. They are working with the ASLM to train regional auditors in quality assessments towards accreditation. So there is an organization that is much concerned, that is much seeing this as a problem. And I know you can agree with me that TB is one of the diseases that is mainly relies on this biosafety cabinet. You can find that other people in HIV, malaria, they are not concerned about this biosafety cabinet. And these days, you can see the advantage of these biosafety cabinets and these labs in diseases like Ebola. They have, BSL-3 have worked a lot to contain this disease in areas where Ebola has been. So we are requesting that an international recognized group sets standards and identifies the regional expertise to train the local people to have these basic skills, so that we speak the same language. Otherwise, if each country tries to do it its own way, we are going back to the same problems. They will say, this is our standard, this is our standard, yet we are all talking about biosafety.
No, I think I would like to come back to what we do as a call for action during the GLI Africa in Uganda, I think 2 months ago. It's to bring all stakeholders in the same fora, like what we have now, and to have this GLI guideline, if it's finalized, and to see what will be the next step. And in this call of action, our message was, how can we use donors Can we use NTP managers? Can we use manufacture and, what can I say? Institution we have in the country like FMS to call and to come with a training center in the region. This is what the end of our call of action. And I think this initiative can help us to move forward the agenda. I can share a small example. In 2009, Rwanda and CDC, it was an initiative from CDC, we can learn from HIV. The network of HIV with the viral load network. CDC developed a plan with South African people to support some country to do safety cabinet maintenance. But out of this program, they need come to say, when the project will end, what will happen? Because these people will be maintained, this will be maintained, but when the project will end, then we will have problem. Then the initiative come to say, why not to begin to plan in our strategic plan, capacity building. Some countries take the lead to do that. Rwanda take the lead to do that, and I think now, provisionally, they don't need intervention from South Africa because they have someone sent to US which received training, then it can build capacity locally. Then I think this is the way we have to go. It will be a transition period where we'll struggle, but we have to do call of action and begin to put all of us unite our force with the same achievement, to have a center of training in the region. This will be the solution for long term. And not only we are advocating for TB, but when we come to the field, the lab is for everyone. Malaria, HIV, microbiology, parasitology, I don't know. Everywhere we will find the same problem. Thank you. This is my observation.
I was just going to say, and as you build this, I think that as a manufacturer, I can say this without breaking my conflict of interest, but challenge the manufacturer to include training as part of the purchase, part of the warranty. If you're going to purchase an extended maintenance, challenge that to be maintenance and training, so that can be a local resource you're building as you go. Don't just make it a 5-year package, then you're done. Bring that in-house. Learn from the people that are there. If you have a manufacturer coming every year, challenge him to be the one that trains your people so that at the end of the 5 years, you're the expert.
But you need to know what you need to be trained on. And that is, of course, if people don't know that, sort of basics, like what am I supposed to do daily? I thought I was talking loud enough. What am I supposed to do on a daily base, on a monthly base, a weekly in between? Because if you don't know that and you receive training, because quite often people that install equipment do some training, but it's like, here's the switch, and there's this, and well, if this problem occurs, call us. So, you know, it's, and of course, if you don't know, I mean, then you don't know what questions to ask, what training should encompass. So there the standards will be very helpful. That if you have a biosafety cabinet, then you need to know about ABCD, and you know, you can have levels. This is what you need to do as a local person working with that equipment. But if then you could have at regional or national, depending on which setting you're in. And then, of course, at some point there's need for the manufacturer to come in. But before that, usually, I mean, with the experts, it was the same thing. Completely clogged up with dust and whatever. Of course, it doesn't work anymore. So these very basic things is what we need to know, and it needs to go in guidelines. And maybe have local laboratory technicians write the guidelines, because they sort of know what their peers can understand.
Go ahead. You gonna sing?
Yes, used to be in a rock band. I was just going to say training, in addition to laboratory procedures, I think also training is needed in management and supervision. Because what I see in labs is oftentimes the people who are supervisors, they're not supervisors because they've been so much better than everyone else in their work. It's just because they've been there longer. And a lot of these people, I find, don't know how to supervise. They don't know how to manage. And so a lot of these things that they should be doing, they just don't do. And so I think people need to be trained on how to be good supervisors and managers.
Okay, go ahead.
That's a big one. We won't go there. So I'm from the old school, you know. In graduate school, we had our equipment. We knew our equipment. The equipment was like my musical instrument. When I play my saxophone, I have to clean it. I have to change my pads. I have to do this. I didn't depend on anyone else. So microscopists should know their microscope. And we should, and this is what I'm saying about our instruments, but in the lab. But they don't do that, and people get these instruments, they're donated, donors put them in there, and there isn't that training component on these of basic maintenance, you know, and basic monitoring and recording, and that's what the LQMS whole thing is about, recording the errors, understanding what's going on with you on a daily basis. It's really hard as a TA to go in and try to do that in 2 weeks. I mean, this is challenging, so there is this whole element that's missing. And it's right, the management don't have a clue when it comes to all of those different things. So, you know, it's a challenging thing, but I do think this is an element also that needs to be addressed.
Can you take your saxophone home at night? Or you take their microscope?
Yeah, and I think essentially what this is raised is, it doesn't matter if you're in the African continent, North America, Europe, or anywhere else, it's the same issues. My wife works in a virology lab at CDC. She came to me one time and said, I don't think my cabinet's working right. And I said, well, why do you say that? And she said, well, I took my vanometer that I gave her, and she said it's about 80 feet per minute, 0.4 meters per second, and it's going in and out now. So I said, well, just call the people, you know, who tested the cabinet. And she said, well, they did just test it. I said, well, good. So she called, and the guy said, well, it passed. And what does that mean? So she doesn't take that as just the answer. So she said, can you send me the report? So we took a look at the report and it said pass, 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 fail, pass, 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 and overall pass. So the velocities failed, but it has a sticker there saying it passed. So if she hadn't taken the initiative to do that, she wouldn't have, you know, she'd still be, well, she wouldn't be working the cabinet because she knew something was wrong, but we need everybody to be able to do that. Not necessarily, we don't want them to take the cabinet apart. We don't want them to change filters. We don't want them to change flow rates. What we want them to do is know how to work in it safely and how to identify situations which we need to raise it to the next level. In some cases, the next level may be a certified person or the manufacturer. It may be something less than that. Everybody should be able to change out a lamp. You know, everybody should be able to, well, except for a few people that I know, change out a fuse. So again, I agree 100% with what you're saying, and we can, you know, start working on that.
Covering the alarm with tape is not fixing it.
Okay, the last one, we're 15 minutes over now. Please.
One before the last.
Okay.
Okay, sorry, I'm joking. I think what we need to keep in mind also is the cost. This kind of biosafety has a cost behind. And if lab component has not moved forward, it's because of the budget. So now we are going through another wave of global fund application, where I think we should really take into consideration these biosafety elements and help countries to budget it. Mm-hmm. Because if we talk about the training, to train lab technicians in A, B, C, D, there is a cost behind it. If it's not well set up ahead, I think the countries will miss this opportunity to be trained on this particular area. I think this is something we need to work on. We might come back to you guys, you know, to hire you to consult in the countries.
You too.
Me too, including, of course. So I think this is the component we need to take into account. The cost is high.
Yeah. Very good. Yeah. Okay. Elaine, do you have any closing comments or?
No, my closing comment will be, I think it's a process, and I see that there are more and more interest, and it's coming even in a regional meeting, and people begin to understand that we have to work as a group, not separated team. And a good thing is that GDF now is aware of this process of doing maintenance contract for 5 years. Last meeting we discussed is not only 5 years, you have to be sure that in the contract you put specification, training, which kind of training, discussing with people who know what we need, because GDF people are not lab specialists. This all information, I think, people begin to understand. And on board, we have new technology like Omni, which is coming. Connectivity is coming on board. Then we don't have to look as a small picture. TB Lab Biosafety is a broad package we have. And to close is that, as we discussed this morning, is to, again, to maintain this kind of discussion at each union conference, to bring and to involve many stakeholders, and this concern can be solved by advocacy and information each other. Guideline is not enough. We have to go behind guideline. Thank you.
So we thank you very much for your time.